Good afternoon, everyone, and welcome from Epson Industrial Solutions Center Plus to today's live event. I'm Kamal Boushib. I'm responsible for international sales for robotic in the EMEA region at Epson Manufacturing Solutions. For today's live event, I'm pleased to welcome Dr. Tamas Lamfalusi from company RobPathRec. Hi, Tamas.
Hi, Kamal.
Welcome to IC Plus.
Yeah, nice to see you.
RoPathRec offers innovative solution to enable both professional and beginners in robotic to program even highly complex robot path within very short time. This is an added value for customers for time saving and cost saving. This technology can be easily implemented for different kind of applications, such as dispensing, gluing, and much more. So we will today, during this session, we will have a live demonstration. But before that, I want to ask you to use the Q&A box to ask your question. We will come to these later on and answer them. So now I pass on to Tamas to introduce himself and the company.
Thank you very much. So thanks for the invitation. And as you mentioned, I really prepared a short presentation for you in which I would like to show you who is behind RobPathRec, what is RobPathRec, what is solution about, how this technology, what we as RobPathRec applying works. We collected some adapters for universal usability for daily usage. You will see this later on, why this is so unique and important. And for sure, the most important part for the session by today is the live demonstration. During the live demonstration, you will learn how do we place our hardware and which kind of hardware do we need for this technology, which kind of software environment we use, and how you can set up in RoboDK a robotic cell station for the usage of the RobPathRec software. We will demonstrate it furthermore on a Scara device and afterwards on a 6-axis device. We prepared 2 demonstrations that you can check out how easily it is to operate and how effective this programming method. Okay, who is RobPathRec? Who is behind RobPathRec? So RobPathRec was founded by Balázs Richter and myself, Tamas Lamfalusi. Balázs is the programming genius behind this project, and he's an active robot programmer, an expert for offline simulation. So everything which is compiled from a daily robot programmer best practice compiled to the usability of a software is coming from him. And me, myself, I am responsible for business development and other tasks in the company. The company is located in Regensburg in Germany, and we founded the company in 2023. So we are very proud of that. Even after such a short time, we can be here at you, and we are allowed to present our knowledge and what we can, how we can help the user for easy robot programming. And what is the easy robot programming, what we are offering? So this is a tool what we created, a hardware tool powered with an own developed software. And with this hardware tool, we are collecting coordinates, X, Y, Z coordinates, and orientation, RX, RY, and RZ orientations, and the position where we should control or we should apply any kind of comments for external controllers, for example, spraying on, spraying off. And all of the data which we are generating will be automatically transferred to RoboDK, into a RoboDK program, which we will show you later on how you can use it. RoboDK is an offline simulation tool, which we are using for a real-time representation of the digital twin. So the whole movements with our tools are real-time shown on a screen, and later on you can manipulate the created program in RobotDK if it's necessary, and then with one click or with a few clicks you can transfer it in a native format to any kind of Epson device. For sure, as we are using RobotDK, this is not only limited for the Epson devices, but we are supporting all of them, even Scara and 6-axis devices. So where such a kind of technology can be used effectively, basically everywhere where you have very complex outlines or surfaces what you want to follow. For example, for welding, for surface treatment like polishing and grinding of surfaces, spraying and paint application, where very fine hand movements should be copied, any kind of gluing application or dispensing where you want to place some fluids on surfaces, and for sure powder coating and sandblasting applications can be supported with our tool as well. For sure, you can use it for pick and place or machine tending applications as well. However, I think for this, because this is very widespread, there are some very good standalone solutions, but our tool supports this kind of application fields as well. And I'm pretty sure once you start to use it for anything, you want to use it for the pick and place applications additionally as well. Okay, how this technology exactly works? Basically, we are using laser scanners with which we scan the complete work area where we will provide and go for the recording. This working area, including the robotics cell, will be copied in a simplified manner into RobotDK. And this is a one-time action, as you have to calibrate the tool center point and the user frame, which is in the Epson devices. I think it's called locals. Typically, it takes approximately 30 up to 90 minutes, depending on the application, and then you are ready to go. As mentioned, you just have to do this only one time. Then you can use this saved and stored setup from time to time again. Before you start with the recording of your workpiece, you have to calibrate the system. This is necessary that we can make it sure that you always have the needed accuracy for this. And especially in a workshop environment, this can always happen that you have some dust or reflections from plexiglass or something like this one. And with this very simple and easy calibration, you can make it sure that the actual accuracy of the system is good enough for your purposes. Once it's complete, then you can really go for the recording of the path. As mentioned, any kind of 2 or 3D surface or outline, any kind of complexity can be easily copied with this tool. And this really, even at long outlines, takes just a few minutes. You will see this later on. Finally, all of the generated data, as mentioned, will be transferred automatically into RobotDK, and automatically there will be a program generated out of this transfer data, which you can simulate on the screen. So you can really check out from point to point if you want, if everything's on a fine place. Once it's secured and you are satisfied with the results, then with one click, you can export it to the native format for the Epson devices, and then you can let it run on your robot. It is often so that the people they are working with our device, they are not used to use such a kind of pen or joystick, but they are really used to use a spray gun, a welding gun, or any kind of real manual tool what they are using for the processing. So for these purposes, we created adapters like a universal adapter, which you can fix on any kind of surface with the 6-pin hose. So you have all of the freedom to find any kind of position what you want. But in the meanwhile, we have ball bearing adapters. We have surface adapter that you really can make sure that the angle of the device is really perpendicular to the surface. You can use edge adapters if you want to follow edges or corners, but for sure, for grinding or surface treatment, we have adapters as well. By the way, the CAD files for these openings for the adapters we deliver to our customers, so they are welcome to develop and play around to make their own adapters for their own usage. As mentioned, this is a very easy stuff how you can 3D print it, and then you can really use it everywhere on any kind of tool. I think I have spoken enough about the theory, and this might be time for a live demonstration, isn't it?
Yeah, I guess so. So that's what we have seen now, 4 steps to the final result. It looks very easy. I think we should demonstrate it now to showcase really in the real world how it works. So
Okay.
let's move to the cell. Yeah, so before we start, let's first introduce our friend here. What we have here a Scara robot from Epson. For the people who does not know Epson well, Epson is not a printer or projector manufacturer, but we do have robots, and we are #1 in Scara robot worldwide now for 11 years successively. So by far, we have the largest portfolio in Scara with 3 lineups, different performance and price level. What we see here is the entry model with the built-in controller, which is simplify the task of setup and so on. 6 kilo payload and 600 millimeter reach. The robot itself is available on our stock normally, and within 4 weeks could be dispatched to the customer in Europe. So, and we have prepared a pad here, or a robot pad, which we will use before. But now for you, Thomas, what do we need really in terms of hardware to set up the recording and your solution?
Mm-hmm. Thank you. So we prepared a very easy tool, a very simple tool for the Scara. This is this white tip on the Scara, what you can see. This simulates our tool, the tool center point, so you can use any kind of tool. We were just going for this very simple solution for this demonstration. As next, I would introduce our 2 laser scanners. This we need for the virtual reality surface scanning of the working area. We deliver 2 of them, and they can be placed very easily next to the working area where you want to process and record the path. As next, I would come to the working area, and as you might see, the working area is here prepared outside of the robot cell, and here you can find our device on. On the device, on the top of the device, you can find our tracker, and the tracker should always has a clear sight to the laser boxes to be able to decide or to record the position and the orientation. As you can see, we have a quite particular form of this device because we prepared it for right-handed usage and for left-handed usage at the same time. This from a very simple reason. Balázs, my partner, is a left-handed person, and myself, I'm right-handed. So therefore, really everybody can use it. You can see on the device as well that we have 4 hardware buttons on a symmetrical manner. We place them, so you can easily use all of them, and you are really ready or free to choose which kind of functions of the RobPathRec software you want to program or to apply to each of the buttons.
So you have predefined features, and the customer can freely program the buttons.
Exactly. We have predefined functions, and you can choose on which button, which kind of function do you want to use. Additionally, here you can see these openings for which I mentioned we provide the CAD files as well, with which you can apply any kind of adapters. And for this case, we just prepared a very easy one. Here, a kind of disc with an alignment pin, and with this alignment pin, we can follow these laser cutted edges very precisely. So we will show you how easy it is to use. So this is all of the hardware what we need for this programming. So this is nothing complicated, quite easy.
Is there any restriction regarding the working area, for example, you have to consider or customer has to consider?
Yes, you are right. Exactly. As you could see, I was just covering the clear side from one of the laser sources to the tracker. This is one of the reasons why we are delivering both of them or two of them. Ideally, you can place them in an asymmetrical manner. That means one laser source will always have a clear side to the tracker, and then it is ensured that you can make any kind of recording without interruptions.
So with two laser scanner, I am done. I don't need more.
Exactly. Even with one laser, you can do the job. But if you have two of them, then you can really make it sure that in any kind of circumstances, situation, you will be able to use the tracker, the device, without any interruption.
So nice. Now this is in terms of hardware. What do we need? You mentioned in the presentation RoboDK and your software. How does this work?
Exactly. So for sure, you need our software, the RobPathRec software, and as a must-have, you need RoboDK as a real-time visualization. You will see this later on, and as an offline simulation and programming tool. We have to make it sure that we copy exactly the same cell, at least the boundary conditions of this cell, into RoboDK, that we are able to do the programming. And it might sound a little bit too complicated. It is not. We're going to show you how easy it is to make it. We can focus on the screen in front of Balázs, and Balázs will show us on an empty RoboDK file how we can build this up step by step, that you can copy the reality into the virtual reality.
Yes. So Balázs will show us how it start from scratch to build up this kind of project.
Exactly. Exactly. As I can see, Balázs already started RoboDK with an empty file. And I would like to ask you, Balázs, that you open from the online library from RoboDK this particular device. This is freely accessible for any user of RoboDK. You can find, I think, over 1,000 devices. We are focusing for sure on the Epson devices. And you can see that all of the Epson devices you can find in this open library.
Exactly.
So once you found the device, what you need, this is this Scara robot behind us, you can just simply click open, and then the device will be automatically downloaded and open in RoboDK. As a next step, just like in the reality, we have to apply a tool. So Balázs will add a tool TCP. This is a coordinate system, which is the tip of the pen. And Balázs will show us that the built-in function, how we can define this tool center point. So therefore, there's a built-in function in RoboDK, and basically you just define one static point somewhere in the working area, and this one static point should be touched on four different manner with a real robot. All of the coordinates, the X, Y, and Z coordinates should be noted and should be typed into this mask. We skip this because we have done it in the preparation phase, but this is really so easy. As a next one, you have to define the working area. So in the Epson wording, it's called local. We call it user frame, but it is the same stuff. So we are talking about the definition of the layer of where we will do the job. Balázs, I think, already added a user frame. And there is an additional built-in function in RoboDK, how you can define this working area. And please open it, Balázs, and then we can see. So this is a built-in function, and with 3 points, very easily, 1, 2, and 3 points, we can define this layer, this working area. And from this point, once we have touched it with the real robot as well, so we noted the coordinates, and we just enter it into RoboDK, we have a 1-by-1 exact copy what we have in front of the robot and what we have here in front of us.
Yeah, so we are lucky today that we have the two paths doubled. So, but there is an advantage behind or a background. Why do we show these not directly to the robot, but here outside of the set?
Yeah, so this is one of the biggest time-saving potentials what you can reach, especially with your industry robots, because just imagine you could measure or you can define the whole working area of the robot, and then you can do the programming offline anywhere. That means your robot is running productive all the time during you are doing the programming. So you don't have to stop it for manual teaching, for anything else. You do not need any CAD files for an offline programming, but you can really generate the CAD file from
the real part.
From the real part, which is created one time uniquely for this purpose, and then you can copy it without any kind of additional efforts to the robots, as long the robot is really doing the productive stuff. Once you are ready with the programming, then you have to interrupt it one time. It takes approximately half an hour. Then you can really check out until the finest details if it's okay, and then you can run further on with your production.
Great. So let's look to what Balázs is doing. So are we ready for demo? Yeah.
Okay, great. So Balázs will show us how to do this. We can focus on his screen as well at the moment. So we have quite clear steps on the screen, what you should do. In this case, you have to touch the origin point with the tool, with the tip of our tool, and you click one button. Then you have to move to the X axis, and you have to press one button, and you move to the Y axis and you press one button. You can see on the screen that the digital twin already moves exactly the same way, the same manner as Balázs moves the device in the hand. And as the last action, you have to go back to the origin and you just click it again. And then you will see if the accuracy is good enough or not. In this case, just like we would have planned this, this was above 5 millimeter. This is very important in our opinion, because if the accuracy is not even 5 millimeter, then we want to tell it to our user that the accuracy will be not as good as it was expected. Balázs just repeats the calibration, and this is the reason behind why the calibration should be done before each run. And right now we are under the 5 millimeters. Unfortunately, I can't get the exact number, but it doesn't matter. We can start with the recording.
So if the accuracy is above 5 millimeter, the user get an error message and they have to restart. This is much easier if you, I think it's fair enough.
Yeah. So you can still decide that you do not care and you can follow up, but you at this point you have the chance. Okay, you have to restart it, wherever it was happened. So what Balázs is right now doing is a very simple task. That he's going to the straight lines and to the arcs, to the start and stop points. And at each point, he just presses one button. With this one, we define these sections, and we will connect the points automatically in RoboDK later on. And we will see that a complete path will be created out of this movement. We have an additional function what you can use for the case if some surfaces or outlines are really very complex and you cannot use only straight lines or kind of circles. In this case, you have the so-called continuous mode. With the continuous mode, you can really record very tight, even at each millimeter points, and then you have a very, very tight point cloud on the screen, what you can go through point by point with the robot. In this case, this is not necessary because we see that these are arcs and straight lines.
So with the teaching we are done now, it is really impressive how smooth the robot is, at least in the demonstration on the software, how it moves. I am really, how to say, I'm expecting in the real life how is the robot is doing afterwards. So yeah. So are we ready for?
Before we started on the robot, we always check it on the screen that we make it sure that we do not crash anything in the reality, because
this is also okay.
Yeah, so this is the last instance. You can always check out on the screen what you recorded, and then if necessary, you can make some changes in the created program. And I think Balázs is already playing on the screen the simulation. So Balázs, if you are satisfied with the results, then please transfer it to the robot, and then you can transfer directly on the robot, and we can then switch to the live screen that you can see in a real movement the robot during the operation. Balázs, you can start the robot, please. Thank you.
Great. This is impressive.
Okay, so this was really without any kind of additional fine-tuning. Hence, we are always recommend that you really go through in a slow motion, and then you can really make the last correction steps for your needs.
Yeah, depending on the requirement of the application and
sure.
on how accurate you should be. This is great. I like it. Now it's done for a Scara robot. We have prepared something for 6-axis, but before that, is there any challenges or any differences between the two kinematics?
Not for us. So for our approach, if it's a Scara or a 6-axis or whatever, this is always exactly the same procedure. The post-processing is done in RoboDK. Therefore, it is so important that we are using with our solution together with RoboDK. So this will always be created with the right post-processor out of the box with your device. So everything, this kind of magic happens in RoboDK, and our procedure is always exactly the same. So it doesn't matter which kind of application you have, you can do always the same, and you will get always the best results.
That's great. So let's move to the 6-axis robot station. I see football, my favorite sport.
Yeah. That's great.
Yeah. So before we start, let me also introduce our 6-axis robot. Here we are talking about an entry model as well. So with built-in controller. This is, we call it VT6, VT6L because of the arm length. The robot can carry up to 6 kilograms and has a arm length of 900 millimeter. Can be mounted in different ways, like tabletop, wall mount, or ceiling mounted. Is existing also in clean room, IP67, and also in DC version with 48 volt. The robot we also keep on stock normally, and we can also dispatch within 4 weeks if required. So this is to the robot side. So this is, I think, is a challenging or more challenging application.
Exactly. So I think this one, what we prepared, this is really a kind of top of the line, what you can imagine. So we prepared a simple football here, and we want to go ahead the joints here around our logo. Why it is so challenging and so interesting. So you have all of these lines, what you have to follow on a sphere. That means you cannot connect them with straight lines. You really have to follow the sphere in any direction. And this would be the highest challenge, I think, for a normal programming approach. So if you want to program it via normal teaching, this might really take a couple of hours, if not even days. And additionally, for this example, the calibration will be exactly the same. So we'll use the 0, the origin, the X, and the Y axis. But as you can see, this calibration area is out of the working area where we will operate later on. So with this one, we want to demonstrate that the calibration area and the operating area must be not exactly on the same place. So you can do this anywhere where you want. It is just very important that at the very beginning, the same points will be driven on with the robot and with the RoboDK station file. So I think this should be clear enough, and I would like to ask Balázs that he shows us how to teach this very challenging project. And I would recommend that we are focusing or using all the time the live camera, because this is the more important, that we can see the procedure is exactly the same. So we are calibrating the device, and right now I'm near enough that we can see that this is approximately 3 millimeters, what we could reach at this particular setup. And Balázs will just touch all of the start and stop points, and we will generate the path afterwards automatically out of these recorded points. I I just want to point here out that you can define standardized offsets for the frame and the tool with our software, and we use it, the tool offset in the Z direction. So we will drive above the surface because we are not so confident with the 3 mm offset, and we don't want to damage the ball later on. But you can define it which kind of standard offset you want to make the recordings, and later on, iterative, you can really touch the surface exactly on the manner what you need with the robot. I think this is still very impressive. So we were talking about that this kind of programming would take at least several hours, if not days. And you could see we are ready within a few minutes. Balázs is just checking on his screen what we created. We can show this on the screen as well. I think this result is good enough that we can switch back to the live screen, and Balázs can transfer the program to the robot and start it on the 6-axis VT6, and we can just check it out if the recording was exactly the same accuracy as we expected from the very beginning. It drives a little bit slow because we wanted that you can capture the results. The speed you can adjust for sure, completely independent of the recording. So you can adjust any kind of speed. Normally in slow-mo, like now, we are just checking out the final results. Once it's ready, then we can go with a fast movement as well.
So what about if I have such path and there is some obstacle in between? What do you recommend, for example?
Normally, we recommend that you always create some segments of the path what you want to record, depending on the complexity. That means you can make some subsequences, and later on, these subsequences can be joined automatically with our software within RobotDK. If you have any kind of adjustment requirements later on, then you can adjust the subsequences, and then you will get a ready-to-use program.
Impressive. Thank you. Thank you, Balázs. So, another thing you have mentioned in your presentation, parts, calibration tools, and some tools, and you brought something with you. So could we show to the customer or to the audience what we have here?
Sure. So basically, we will showcase you here what are the hardware components which you will get if you decide to use the RobPathRec tool, which might be the best choice for a quick and easy programming. So first of all, you get a weather and shockproof case for the transportation of these techniques. What we deliver you, this is the 2 laser boxes. For the 2 laser boxes, we are delivering magnetic foot with a ball head, and with this, you can easily adjust the right angle for the laser boxes, what you need. For sure, for both of the laser boxes, we are providing the power adapters. Additionally, you get one USB connector for charging the tracker. We provide for each kit an easy calibration tool. This is a very small one, so we recommend to use the big as you can, but this is a very small one, so you can use it everywhere. If you don't have anything to your hand what you could use, then this tool is always there. For sure, you have the USB adapter with which you can connect the tracker to the PC, and the most important is the device, which is the latest generation. We improved the haptics, so this is really a very good feeling to get it in your hand, and we improved the adapter openings, so you can really fix and click all of the adapters quite tight onto the pen, and then you can make it sure that it is very fixed and very easy to use.
What is this?
Yeah, this is a spray gun. Yeah, this is a good question. This is not part of the delivery package because we don't have the space for this. We just wanted to show you how easy it is to use with a real tool. So we just designed an adapter for this purpose, and you can just put in the pen, and then you can really copy the finest hand movements for a spray gun, for example, and then you can record the path. So everybody who is in the painting business, they can really use it smooth and easily without any big programming knowledge.
Okay,
Thank
great.
you.
So robot is not a part of the delivery, I think.
That's correct. That's correct.
What about the tripods we have seen now here in the setup?
Okay, on the tripods, this is not part of the delivery, but we can give you recommendations if you need which kind of accessories you should use.
Okay. So thank you for the explanation. I think we should move back to the desk and see if there is any question from the audience. Okay, so we have a number of questions. This is good. So first question, is it necessary to have the not free application RoboDK?
Yes, because with this, you can make it sure that you can save and reuse the generated points. I think the free version is limited to 50 points. This is the one. The other one is, I think this should be for the fairness. RoboDK is a great piece of software which we are using for our solution as well. And for sure, their efforts should be respected as well.
Okay. Another question, how to record the Z-axis moves for Scara?
This works the same way, so you can just simply move the device and the Z-axis movements will be automatically recorded, and this will be compiled into the native code for the Epson robot.
Okay. So I see here maybe one or two questions about the price. I think we will talk about this later on, or at least we will handle this question afterwards. One interesting question here is on the 6-axis, how do you ensure the pointer is perpendicular to the ball surface?
In this case, it was not the case, so we didn't care about, but you can use for this an adapter as well, so you can make it sure. The other way is that you can record this path as you can, and later on you can correct it in RoboDK. An additional feature, what you might want to know, that you can fix the orientation. So with one point, you can define exactly the orientation what you want to use, and this orientation you can copy to each other points as well. So there are a couple of ways how you can do this online or offline.
A further question, does your software only teach the point, or does it write the whole program code?
Okay, this is a complex question. So we collect the points and we write the trigger into the code at the right time for the external controller. The program code will be generated via the RoboDK post-processor. So a simple answer to the question, yes, you will get a ready-to-use native program to your robot device, but our device is not taking care about the creation of a complex program, but we are just recording the room coordinates and we are just recording where a tool should be switched on or off.
Another question here, how large may the working area for the recording should be?
Okay, a very good question. We recommend a minimum area of 1 × 1 meter because of the optics to avoid any kind of interference. The maximum area what we can cover is 10 × 10 meters. If you need even a larger workspace, then you can use more sets of boxes, and then you can build up several 10 × 10 meters work areas next to each other, and then you can combine them in RoboDK.
Great. Another question, how can the pad be corrected? So can I have the possibility to adjust out my pad afterwards?
Sure, definitely. So this is exactly the point why we are doing on this way as we do. So you record the points, and afterwards you have the possibility either in RobotDK or in your software, in the RC Plus software, to change any point individually, or for sure you can make batch operations. But this is the unique way that this is not a no-code solution. It is a very easy to use, but you still have the freedom to change anything what you need on the program.
Thank you. So this will lead me to another question. What accuracy could be achieved with the system?
Okay, sure. We could see that even during this demonstration, we could achieve different kind of accuracy results. So we say that approximately 2 up to 3 millimeters can be reached during any kind of circumstances where you're really taking care about that there are no dust or any disturbing elements for the optics. Normally, if we are set up the system, we reach approximately 1 millimeter accuracy or even below for the optical system. We never wanted to reach really below the 1 millimeter because this is a freehand operation, and just because of the freehand operation, there will be always an inaccuracy in the system. So the short answer, up to 3 millimeters, this should succeed anytime. And with some exercise, I think you can come into 0.5 up to 1 millimeter.
Another question here, how many PCs can the software be installed on?
Oh, yeah. We have different kind of licensing models. If you allow me, I would show it to you to answer your question. So this is, we are just prepared different kind of bundles. If you do not have anything, so you don't have RobotDK, you don't have anything of our bundle, then we recommend you the complete one, in which you get the hardware, 1 month usage ticket for our software, and the RobotDK. If you already have RobotDK, then we have the RobPathRec only package. With this one, you can use our hardware and our software for 30 days. And here's the answer to your question. So if you are using usage tickets, we offer them for 7 days, 30 days, or 1 year, so 365 days. That means during you have a valid license, you can use it on any number of PCs what you have. However, one license can run only on one PC at the same time. So this is clear, but you can install it onto 100 PCs, 1000 PCs, any number what you want. If somebody needs, we have a new developed lifetime license. The big difference is with the time-based usage, you get always the latest software. So you are always ready to download the latest software with the latest features, with everything twists and bezels. With a lifetime license, you get a frozen function of the software, but you do not need any additional licensing. And if you want to use the latest features, then you have to opt in for a maintenance package.
It's great. So for each requirement or each customer needs, you have the right package.
Exactly. Small, big, often rare. We can cover any of the requirements. That's good.
So in terms of robot number of robots you can teach, it is also a limitation or no limitation how it works.
No limits. If you have a valid license, you are ready to go for unlimited robots. You can teach 24/7 as many robots as you can.
So one investment and so
exactly.
you can use for many. Yeah, this is great. I had the last question is, does the customer need internet access for teaching?
Mm-hmm. So indeed, for the time-based, usage-based tickets, you need internet access because we check the validity of the license via internet connection. If you are opting in for a lifetime license, then you do not need even the internet connection, and then even the updates should be installed manually.
Let's have a look again on a Q&A box. Okay, which is the installed base actually? I don't catch the question. So
I do not really understand the question neither, but I try to give some kind of answer. I hope I can meet the requirements. So basically, we have We are not working in the base of the vert, not in the vert coordinate system of the robot, but we are using on the user frame in the local, and therefore the local you can move anywhere you want. One time it's defined the definition or the position to the vert coordinate system of the robot, then you are always ready to go. So we are using the user frame, the local, as a base.
I believe the question was how many of the products are already installed in the market.
Okay, I don't want to give you any concrete numbers because we have some NDAs on, but it's more than enough that we are confident that the solution is working very well. And maybe I can tell you we have in the meanwhile all around the world customers, so it is not just working in our location, but really all around the world. Until New Zealand, we have customers, they are happy with the solution.
That's great. Yes, we have some price requests. I will suggest if someone is interested in pricing, we have seen there is too many packages and bundles, so it's better to get in touch afterward with you, and then you can depending on the requirement, you can of course send the right price and so on. So yeah. So I don't see any further question. So that's why I want to thank you at this point, Thomas. It was very interesting, very impressive how it works. We have a live demo and we could showcase how easy and how time saving and of course cost saving your solution is. I think customers are the same opinion and the audience as well. So thank you very much for coming and thank you for the explanation.
Thank you very much.
Yeah. So yeah, then from my side, I would also to thank you all for your participation. Just one thing, I just want to make you aware about our Industrial Solutions Center Plus. You can book a session here online. We have a landing page. My colleague will display the right address where you can book an appointment. You will also have someone here. This is which we call a hybrid presentation, because we are in real here, and then we can explain what Epson has in a portfolio. What do we offer? We don't have only robots. We have other options like feeders, force sensor, and vision systems. So get in touch with us. We will be pleased to support you also in your requirements. So at this point, thank you very much for attending. Thank you, Thomas, again, and bye-bye.
Bye.